So we know the distance from any point to a line is the perpendicular distance. So when all the lines passes through the same common point, they are called as concurrent lines. If I find the point of intersection by knowing the equations of line, then I can easily find point M. There is another line which is passing through the same point of intersection, then it is called as the concurrent lines. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session in the chapter straight line, we are going to discuss about the point of intersection of straight line. So what do you mean by this point of intersection? We know in a point there can be many lines passing through this point. So when a given lines or when a certain lines are given, we are going to find their point of intersection. So that is what the point of intersection of a straight line. And concurrent lines means a line which is passing through the same common point. So these lines are called as concurrent. So this is called as point of concurrency. So here in this session, we are going to study about the point of intersection as well as the concurrent lines. Now let us take the problem. Find the point of intersection of the line x plus 5y plus 4 is equal to 0 and 3x minus 4y minus 7 is equal to 0. A very simple method to solve or to find the point of intersection is to solve the simultaneous linear equation. So this is in the form of a linear equation, and we have learned in the chapter linear equation or solving equations. There are methods of comparison or methods of multiplying, also using the formula method. So here we are going to solve the simultaneous linear equation and we will find the point x comma y, which will be the point of intersection. So here we have an equation x plus 5y plus 4 is equal to 0 and 3x minus 4y minus 7 is equal to 0. So now here we do not have any common constants or coefficients to add or subtract these equations. So what I'll do, I'll multiply the coefficient of x3 here and same, it's multiplied with 1. So this becomes 3x plus 3 5s are 15y plus 3 4s are 12 is equal to 0. And this remains the same, 3x minus 4y minus 7 is equal to 0. Now let's subtract this. When you're subtracting, you will change the sign in the second term. So now this becomes 15 plus 4, 19y plus 19 is equal to 0. So we have y is equal to minus 19 by 19. So the value of y is minus 1. And if we substitute y is equal to minus 1 in any one of the equation, so we get x minus 5 plus 4 is equal to 0, x minus 1 is equal to 0, x is equal to 1. So therefore, the point of intersection x comma y is 1 comma minus 1. The solution of the simultaneous linear equation becomes the point of intersection. Next one, find the equation of the line through the point of intersection of 2x minus 5y equals 1 and 3x minus 2y is equal to 8 and parallel to the line 2x plus y is equal to 3. So we have two lines here. One line can be taken as 2x minus 5y is equal to 1 and the other line is 3x minus 2y is equal to 8. So we have a straight line here which is passing through this point of intersection. And this is parallel to one more line. So these two lines are parallel. So using these conditions, we are supposed to find the equation of the line. Now, since point of intersection is the point on the required line, first let us find the point of intersection. Solving these two equations. 2x minus 5y is equal to 1. 3x minus 2y is equal to 8. So let's multiply the coefficients of x. Here it is 3 and here we'll take 2. So 3 2s are 6, 3 5s are 15, 3 1s are 3. And here 2 3s are 6, 2 2s are 4, 2 8s are 16. Subtract minus plus minus. Cancels. So here it is minus 11y and here it is 16 minus 3 minus 13. So y will be equal to 13 by 11. Now if we substitute 13 by 11 in any one of the equations, so 2x minus 5 into 13 by 11 is equal to 1. We'll get 2x is equal to 13 5s are 65 by 11 plus 1, which is 65 plus 11 by 11. So which can be written as 76 by 11. So cancelling this, we'll get x is equal to 38 by 11. Now the point of intersection is x comma y, which is equal to 38 by 11 comma 13 by 11. So the required line is, passing through 38 by 11, 30 by 11 and parallel to, so the given line is 2x plus y is equal to 3. 2x plus y is equal to 3. So this implies slope will be equal to the same line because the required line is parallel to the line and hence their slopes must be equal. So here the slope m minus a by b form when general equation is given. So therefore it is minus 2 by 1, which is equal to minus 2. Now using the point slope form, the required equation can be written as y minus y1 is equal to m into x minus x1. So this is the point slope form. So here x1, y1 is the point of intersection and slope is minus 2. Y minus 13 by 11 minus 2 x minus 38 by 11. So then this becomes 11y minus 13 by 11 minus 2 11x minus 38 by 11. We can cancel 11 on both sides. So minus 22x becomes plus 22x plus 11y and minus 13, 32 into x will get minus 89 is equal to 0. So this will be the required equation of a line which is passing through the point of intersection of these two lines and parallel to the third line. Next one, find the coordinate of the foot of the perpendicular from minus 6, 2 on the line 3x minus 4y plus 1 is equal to 0. So let us consider this as a point P, which is minus 6, 2. And here is a line here. And this line is 3x minus 4y plus 1 is equal to 0. So we know the distance from any point to a line is the perpendicular distance. And when I say the perpendicular distance, we have a point of intersection on the line. So let that be M. And I'll write it as x, y. Now we are supposed to find this point of intersection. So we can clearly see the line PM or the line segment PM is perpendicular to the given line. According to the condition, if two lines are perpendicular, then the product of their slope is equal to minus 1. So therefore, the slope of PM will be the reciprocal or the negative reciprocal of this. So if I consider the slope of PM as M1, then the slope of M2, that is like this, will be equal to minus A by B, which is minus 3 by minus 4, which is equal to 3 by 4. So then M1 will be minus 4 by 3. So we have minus 4 by 3. If 3x minus 4y plus 1 is equal to 0, then any line perpendicular to this line will have 4x plus 3y plus k is equal to 0. So thus interchanging the coefficient and also changing the sign and constant value will be different. So any line perpendicular to other line. For example, if ax plus by plus c is equal to 0, then any line perpendicular to this can be written as bx minus ay plus k is equal to 0. So here the coefficients interchange and the sign in the second term interchange, whereas the constant is completely different. And hence, without finding the slope also, we can directly write the equation. But any line which is parallel to this line will have the same equation, but with two different constants. Here it is C1 and here it is C2. We have already learned this. So parallel means same coefficients of x and y, but perpendicular means opposite coefficients with change of sign in the second term, because their product is the negative reciprocal of each other. So now let's take here, the required line is of the form 4x plus 3y plus k is equal to 0. So let me consider this as equation 1 and this as equation 2. Now that means the equation of PM is given as 4x plus 3y plus k is equal to 0. See here, PM is a line and point minus 6 comma 2 is on the line PM. That means the line is passing through minus 6 comma 2. Since equation 1, that means the line is passing through minus 6 comma 2, we have here, we can substitute 4 into minus 6 plus 3 into 2 plus k is equal to 0, which is minus 24 plus 6 plus k is equal to 0. So therefore k is equal to 18. Hence equation 1 becomes 4x plus 3y plus 18 is equal to 0. Now let me consider this as equation 3. So why I need equation 3? Because the line 3x minus 4y plus 1 and the line segment PM have a point of intersection which is the foot of the perpendicular. So that's why if I find the point of intersection by knowing the equations of line, then I can easily find point M, which is the foot of the perpendicular, also the point of intersection of both lines. Now I have equation 1 and 3. So that is 3x minus 4y plus 1 is equal to 0. 4x plus 3y plus 18 is equal to 0. So let us solve this. So let's multiply the constants here. I'll multiply coefficient 4 and I'll multiply coefficient 3 here. So 4 3s are 12x minus 4 4s are 16y plus 4 equals 0. 3 4s are 12x, 3 3s are 9y plus 18 3s are 54 is equal to 0. Now let's subtract minus minus minus. So both are minus 25y. Minus 54 plus 4 is minus 50 is equal to 0. So we have minus 25y is equal to plus 50, or y is equal to minus 2. Now y is equal to minus 2. Let me substitute here. 3x minus 4 into minus 2 plus 1 is equal to 0. So 3x plus 8 plus 1 is equal to 0. 3x is equal to minus 9. X is equal to minus 3. So therefore, the point x comma y is equal to minus 3 comma minus 2. So which is point M. So here M is the foot of the perpendicular, also the point of intersection of the line PM as well as 3x minus 4y plus 1 is equal to 0. Next one. Find the image of the point 2, 3 on the line 3x plus 5y plus 4 is equal to 0. So we have a line here whose equation is 3x plus 5y plus 4 is equal to 0. We have a point P, let it be 2, 3. If this is a point P, then its reflection will be opposite to the line at its same distance. So let this be Qx, y. And let M is the point between these two lines, or M is the intersection of these two lines. Also M is the midpoint of PQ, because when I say reflection, the distance of a point PM is same as the distance of a point QM. So therefore the distance will be the same. PM is equal to QM, but obviously point P is the reflection of point Q. They lie on the either side of the line, and hence M acts as the midpoint of P and Q. Now here, again, we will find the equation of PQ. Clearly, these two lines are perpendicular. Now, the equation of one line is given. So, therefore, equation of PQ can be written as 5x minus 3y plus k is equal to 0. So let me take this as equation 1 and this as equation 2. Because they are perpendicular to each other, I am interchanging a, b values with negative sign here. Now, since this point P2, 3 lie on the line PQ, I can use 2, 3 as a solution. So, 2, 3 lies on equation 2. So, this implies 5 into 2 minus 3 into 3 plus k is equal to 0. So, 10 minus 9, 1 plus k is equal to 0. So, therefore, k is equal to minus 1. Now, if I substitute k is equal to minus 1 here, equation 1 implies 5x minus 3y minus 1 is equal to 0. So, therefore, this is equation 3. Now, let me find the point of intersection M solving these two equations. So, that is equation 1 and equation 3. So, we have 3x plus 5y plus 4 equals 0 and 5x minus 3y minus 1 equals 0. So, since I do not have any common coefficient, I will multiply 5 here, I will multiply 3 here. So, 5 3s are 15x, 5 5s are 25y, 5 4s are 20 is equal to 0. Here, 3 5s are 15x, 3 3s are 9y, minus 3 is equal to 0. So, let us subtract. When you subtract, this get cancels. So, this is plus 25 plus 9 is 34y and plus, so plus 23 is equal to 0. So, here solving this, we will get the y value as minus 23 divided by 34. Now, let me substitute this in any one of the equation. For example, 3x plus 5y minus 23 by 34 plus 4 is equal to 0. So, 3x is equal to, so 23 into 5 divided by 34, 115 by 34 minus 4. This is equal to, which will be equal to 21 divided by 34. So, 115 minus 34 into 4. So, we will get minus 21 by 34. So, now we can also cancel 3 1s are 3 7s are. So, x is equal to minus 7 by 34. So, this is M, which is point of intersection, also midpoint of PQ. That is minus 23 by 34, comma 7 by 34, minus 7 by 34. So, the point M is the point of intersection of two lines as well as the midpoint of PQ. Now, since this is a midpoint of PQ, we need point Q. So, using midpoint formula, Q using midpoint formula, minus 23 by 34, comma minus 7 by 34 can be written as x plus 2 by 2, comma y plus 3 by 2. So, we know the midpoint formula is x1 plus x2 by 2, y1 plus y2 by 2. We already have x1, y1, x2, y2 here, which I have taken in the form of x, y, 2, 3. Now, let us solve this. X plus 2 by 2 is equal to minus 23 by 34. And this side we have y plus 3 by 2 is equal to minus 7 by 34. So, that is equating the coordinates, x to x coordinate, y to y coordinate. So, here we can cancel 17. So, x is equal to minus 23 by 17 minus 2. So, x is equal to minus 57 by 17. Next, here we have again 17. Y is equal to minus 7 by 17 minus 3. So, y is equal to minus 58 divided by 17. So, we have x and we have y. So, therefore, q x comma y is minus 57 by 17 comma, minus 58 by 70. So this is the point or the reflection of the point 2, comma 3. The next question is, here we have concurrent lines. So I already said that there are many lines which passes through the same common point. So when all the lines passes through the same common point, they are called as concurrent lines. Now the 3 lines are said to be concurrent if one of the line passes through the point of intersection of other 2 lines. Suppose we have a 2 lines which has a point of intersection, and there is another line which is passing through the same point of intersection, then it is called as the concurrent lines. Now, we have a shortcut method to show that the 3 lines are concurrent. So, let A1x, B1y, C1 is equal to 0, A2x, B2y plus C2 is equal to 0, A3x, B3y plus C3 is equal to 0 be the 3 lines. Then, the 3 lines are concurrent if this is the formula A1 B2C3 minus B3C2 plus B1 C2A3 minus C3A2 plus C1 A2B3 minus A3B2 is equal to 0. So this is same as the area of a triangle which you have learnt in the analytical geometry. So there you have taken it in the form of x1 y1, x2 y2, x3 y3. In the same way, you need to show that these values will become 0 so that it will be concurrent. Or we can also use the linear method of solving simultaneous equation together to find the point of concurrence as well as to show that they are concurrent. Show that the straight lines given by 4x plus 7y minus 9 is equal to 0, 5x minus 8y plus 15 is equal to 0, 9x minus y plus 6 is equal to 0 equations are concurrent. Also find the point of concurrence. See, if we find the point of intersection for these 2 lines, and that point of intersection, if we substitute here, it should equal to 0. In that case, we can directly say they are concurrent. Also, by finding the point of intersection, we also found point of concurrence. Now, let us solve any 2 equation. You can choose any 2 equation to find the point of concurrence and then substitute that point in the remaining equation to show that it is equal to 0. So, I am considering the first 2 equation. 4x plus 7y minus 9 is equal to 0. 5x minus 8y plus 15 is equal to 0. Here I am multiplying the coefficient 5 and here I am multiplying 4. So this becomes 20x plus 35y minus 45 is equal to 0. And here 20x, 32y, 60 is equal to 0. So solving this, we will get y equals 105 divided by 67. Now substitute in any one of the equation, the value of x will be equal to minus 33 divided by 67. So therefore, point of intersection is minus 33 by 67, comma 105 by 67. Now, if the line passes through this point, then the equations should be equal to 0. Now, consider 9x minus y plus 6. So, let us substitute the values of x and y here. So, 9 into minus 33 by 67 minus 105 by 67 plus 6. So, solving this we will get minus 402 plus 402 divided by 67. So, which will be equal to 0. Now, since the point is satisfying the solution, that means the given line is passing through point of intersection. So, therefore, clearly 9x minus y plus 6 is passing through. So, passing through minus 33 by 67, comma 105 by 67. So, therefore, point of concurrence is equal to minus 33 by 67, 105 by 67. Now first let us find this point of intersection. If the third equation passes through the same point, then obviously equation will be equal to 0 and we are getting it as 0. So therefore the point of intersection is the point of concurrence. Next one, find the value of A if the lines x minus 2y is equal to 1, 2x plus y is equal to 7 and ax minus 5y is equal to 4 are concurrent. So let me solve these two equations. X minus 2y is equal to 1, 2x plus y equals 7. So we can also use the substitution method to solve this equation. So here we can write this as x is equal to 2y plus 1. So substituting here in the place of 2x plus y, 2y plus 1 plus y is equal to 7. So 4y plus 2 plus y is equal to 7, 5y is equal to 5, y is equal to 1. So this is comparison method we can also use without solving simultaneous linear equation also. We can take x value of one equation in some other equation to find y. Later on we can get back x. Now if you put y is equal to 1 here, we will get 2x plus 1 is equal to 7. So 2x is equal to 6. Therefore, x is equal to 3. So, what does it shows? 3, 1 is the point of intersection. Also concurrent. Because they have clearly told these three lines are concurrent. Now, since this is a point of intersection and we have one more line which is passing through this point, so therefore it acts as a point of concurrence. So, therefore, we have ax minus 5y is equal to 4. Substitute x and y, which becomes 3a minus 5 is equal to 4. 3a is equal to 9. A is equal to 3. Hence, the value of a is 3. So, using the point of concurrence, we have found the value of A. The next thing is, we have a sign of ax plus by plus c based on the position of 2 points. Now, suppose, let me consider 2 points. This is point x1, y1. This is point x2, y2. Now, if x1 and y1 lies on the same side or opposite side, how to recognize this? See, if they lie on the same side, so this is on the opposite side, this is on the same side. Either it will be like this or it will be like this. If they lie on the same side, then if you substitute x1, y1 in the equation and x2, y2 in the equation, either both will have the positive value or both will have the negative value. That means both will have same sign. Either both are greater than 0 or both are less than 0. That means either they are positive or either they are negative. But if suppose they lie on the opposite side, then obviously the sign of the equation changes. That means one may be greater than 0 and the other is less than 0. So to decide this, we will substitute the point on the given equation of line and then verify whether they lie on the same side or on the different side. So let us take the problem. Show that the point 3, minus 1 and minus 2, 5 lie on either side of the line. That means whether they are on the opposite side of the line. We have 3x minus 7y plus 8 is equal to 0. Let's take this as equation 1. Now 3, minus 1 if I put here, then it is 3 into 3, 7 into minus 1 plus 8 is equal to 9 plus 7 plus 8, which is 24. So greater than 0. Next we have 3 into minus 2. I am substituting this point on equation 1. Minus 7 into 5 plus 8 equals minus 43 less than 0. See, the sign of the first line is positive and the sign of the second equation is negative, which is less than 0 and greater than 0. So obviously we can conclude that the point lies on either side of the given line. Next, show that the point 0, 0 and 2, 1 lie on the same side of the line. So let me take this as equation 1. Put 0, 0 here. Then we will get 2x minus 3y plus 5 is minus 5, which is equal to 0 minus 5, which is equal to minus 5 less than 0. Next we'll put 2, 1. 2x minus 3y minus 5 is equal to 2 into 2. Next minus 3 into 1 minus 5 is equal to 4 minus 8, which is equal to minus 4 less than 0. So both have negative sign, which is less than 0. So clearly we can say that they are on the same side of the line. So if both are greater than 0, both are less than 0, it lies on the same side. But in case if they lie on the opposite side, their sign also changes. So this is how we will verify about the position of a point with respect to the given line. So hence in this session we have discussed about the point of intersection as well as the concurrent lines. So this is all about the chapter straight lines and the end of your first PUC basic mathematics. So I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.